Hi guys, welcome to 315 part 2. This is where we're going to try and put some things together that we've been doing and also look at average rates of change in the context of polar functions. All right, so I think I'm sharing my screen, hopefully. Let's just make sure. You're probably like, yes, you already are. Or no, you're not. Okay, now I am. All right, so we talked about last time distance from the pole, all that, and we can also find average rates of change with polar functions. All right, so I want you to take a second, pause the video, okay? Try to fill out based on these values of theta, plug each of them in to this, and find the R value. Take a second, don't wait for me, do it, pause. I hope you're paused. I hope you're like, I've already done this, Miss Sarsky, because I paused the video and I listened. Okay, so I'm gonna go ahead and fill this in. All right, so check your numbers, make sure they match with mine. Okay, and then average rate of change is the exact same as what we've been doing all year. F of B minus F of A over B minus A. So this is between, this is our A and this is our B. So this would be pi over 2 minus pi over 3. Okay, let's go ahead and simplify that denominator while we're here. So pi over 2 is really the same as like 3 pi over 6. Pi over 3 is really like 2 pi over 6. So if I subtract them, I just get pi over 6. Well, f of pi over 2, that's negative 3. I just get that right from the table. Minus pi over 3 minus 0. So I get negative 3. Let's keep change flip. And this should look like something that was on your last test where we computed the average rate of change between two values. You did something like that. You got some answer that looked like that. So what that means with the relation of r and theta is it's changing by negative 18 over pi per radian. Weird things to think about, but that's essentially what's happening. Again, I'm not probably going to ask you to interpret that, but that's the big idea is that's how much the r, the radius, is changing per radian that it travels. Okay, let's do one more. Let's do from theta equals 0 to pi. So it'd be f of pi minus f of 0 over pi minus 0, which would obviously be pi on the bottom. That does not look like a pi. All right, f of pi, go to my table, is negative 9. Minus f of 0 is 3. So I get negative 12 over pi for this. So if I'm asking myself, is it changing faster between 0 and pi or pi over 3 and 2 pi? My answer here would be between pi over 3 and, or not 2 pi, pi over 2, okay? Because this slope, okay, if you think about average rate of change of slope, that would be steeper, okay? If you computed it in your calculator. Negative 18 divided by pi is about negative 5.7. Okay, and that's about negative 3.8. So if you think about the absolute value, which one would have the steeper line? They're both negative, but the negative 5 is going to change at a faster rate. All right, let's answer this question at the bottom. Is the distance between f of theta and the origin, or the pole, increasing or decreasing? So we're talking about the distance. So that means we're looking at two things. Is r positive or negative? And is r increasing or decreasing? So on this interval, from pi over 3 to pi over 2, all right, well, to go from 0 to negative 3, that means that I am negative. And to go from 0 to negative 3, that means that I am decreasing. Why can I not spell? So if I have a negative number like negative 5 and I'm decreasing, then I'm at negative 10. That means I'm getting farther from the pole. Okay. Now I'm going to write this out with an explanation of kind of like what you would need to write out in calculus. You'd use something called derivatives, but just the point of this. So the distance between f of theta and the origin is increasing because r is negative and decreasing. I know that seems like a lot of words because it is. Just take AP Stat and there'll be 10,000 times more words, but that is what you're looking for. If you just say the distance is increasing because it is negative and decreasing, you're not going to get full credit. So just be very careful. Get in the habit now of writing out with specific vocabulary. Okay. Now let's go to this page where we kind of do all the things. So we have this 3 plus 3 sine of theta. That's going to be a cardioid. It's going to look like a heart. Take a second, pause it, try to fill out your table of values. If you need to use a calculator to get the decimal approximations, that's fine for some of these, just so we can kind of see what's happening. Hopefully you've paused it, you've tried it. Oh, not 1.50. That last one should be 3. All right, so this is what it should look like. So the symmetry, because it's a sine, that's going to have y-axis symmetry. You'll also see this written as theta equals pi over 2 symmetry. If we think about where pi over 2 is, that is the y-axis. So sometimes they word it that way instead. This is a cardioid. Okay, because that A and B are equal to each other. Values where f of theta equals 0 in a full cycle would be at 3 pi over 2. And then if I sketch the curve, it is a sine positive, so that means it's going to go up to 6 because that's 3 plus 3. It'll go out to 3 on both sides. And it's going to look something like that. All right, so extreme where we're thinking about where's the maximum distance from the pole. Well, that's going to happen at 6. So there's a max of 6 at theta equals pi over 2. Hopefully that notation looks familiar from earlier this year when we did that with max of y at x equals whatever. All right, determine the intervals where f is increasing and then where f is decreasing. Well, let me highlight this out. Where it's increasing would be from here to here. And then it starts decreasing, 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 and then it's increasing again, which means this section right here is decreasing. So if I was going to write this out, it would be increasing from 0 to pi over 2, and then from 3 pi over 2 to 2 pi. And then decreasing would be the blue, pi over 2 to 3 pi over 2. Remember, we generally use parentheses with increase, decrease, because at those endpoints, it's neither. And what we say is the derivative would be 0. Again, you don't know what derivative is. It's just really a rate of change is 0. All right. On the interval pi over 2 to 3 pi over 4, is the distance between f of theta and the origin increasing or decreasing? This is the question we just did, but in a different context. So pi over 2 to 3 pi over 4 is this right here. So r is positive, and we are decreasing. That means we are getting closer to the origin. Okay, if I have a positive number like 10, and I'm decreasing, then I'm at 5. That is closer to 0. So I'm going to write out this sentence again. The distance between f of theta and the origin is decreasing, meaning it's getting closer, because r is positive and decreasing. Okay. I'm going to leave G for us to do in class when we deal with kind of using the average rate of change to estimate something. Okay, but this kind of wraps up all of the polar curves and also everything in 314, 315, and all of this big unit. There's a lot of stuff. Remember, all the way back, we started with graphing tangent, and now we are graphing polar curves. So there's a lot of information on this test. There'll be a lot of stuff tested, but that's kind of what's happening there. Have a great rest of your day.